now it's time to add some obstacles that our active ragdoll can interact with. So let's go into models and let's go into the K variety kit and find the swiper. So swiper, and let's do swiper team blue, and let's add that and just put it on the ground. Oops, 0. And this swiper we wanted to rotate and also work with networked objects. So we need to write a script that takes care of the rotation of this object. So let's go and create a new script under network, and let's call it network rotate object, and let's open that in Visual Studio. Now to get the swiper to work both on the host and the client, we need to network enable it. So let's use Fusion and then change our modal behavior to network behavior instead. And there are two ways we can rotate this. Either that we are adding a rigid body to it and using the network rigid body to update it, or that we just update the transform. So in this network rotate object class, we're going to add support for both. So let's take a serialized field and add our rigid body 3D. And then we need to figure out, okay, how much are we going to rotate this? So in that serialized field, vector3 rotation amount. And as with anything on Fusion, we need to run it in our fixed update network, and we need to make it public override void fixed network update. And in this network update, we need to check first of all that we are allowed to rotate it, and only object that has state authority, so only the host or server, can rotate it. Clients are not allowed to rotate anything. So now that we have established that we have the state authority, we are allowed to rotate it, then we can start working on the rotation. So first of all, we need to figure out, okay, how much are we going to rotate it this frame? And we'll take our transforms, rotation, Euler angles, and then we will add rotation amount. So rotation amount is going to be some value that we set. If we're going to rotate it around the y-axis, then just add a amount to it. And then we will multiply it by runner time, delta time. Okay, so now that we have established that we are created our rotation, then we can apply our rotation here. So if we have a rigid body 3D and it's not null, in that case we are going to use the rigid body move rotation and put in our quaternion, and it's based on Eulers, so let's do quaternion Euler and then feed our rotate by in there. And similar, if we have our transform that we are rotating directly, then let's do transform rotation is equal to quaternion Euler rotate by. So let's save that and try it in Unity. So take our swiper team blue and add our network rotate object, and then we have this warning, this network behavior requires a network object, so let's just hit add network object. And then rotation amount, let's put it to 200, and let's make a prefab out of this. Level parts, swiper team blue. And we also need a collider on it, so let's add that in our prefab. So let's add a mesh collider, and then let's save it and go back and hit play. Alright, so now we can see that, okay, it's rotating, and it should be working for clients as well. And if we are getting hit by this swiper, it's something, but it's very easy to sort of avoid it, and not much really happens. So instead, let's change this so that if we are getting hit by something, then we are going to change into ragdoll mode, and that allows our character to maybe fly a bit further, and not to, for the player to lose control for a short period of time while we are ragdoll, and then we can stand up again. So let's stop our game from running, and then we want to add this functionality. So let's go into our scripts, and let's find our network player and open that in Visual Studio. When we are getting hit by our swiper, we want our character to become a ragdoll, and then with the ability to become an active ragdoll again. So we need a state here to determine if we are an active ragdoll or not. So we are starting off as an active ragdoll, and when we are becoming a regular ragdoll, the difference will be that we are going to take our main joint here, and we're going to disable our slurp drive, so that we fall down again, and then we need to do that on all of our joints. But let's start with the main joint, and we need to store our position string here, or not position string, our position spring. So let's create a new float, start slurp position spring, which is going to be 0. And when we are starting up, we are going to take our main joint slurp drive position spring. So main joint slurp drive position spring, and we are going to store that as our start slurp position spring. Then we know what our start value is, and when we are becoming or restoring from being a ragdoll, then we know what we should set this to. So let's scroll down and see. This is an event. Spawned is also event. So here, let's make a public, or let's make it void make ragdoll. And then let's say void make active ragdoll. So then we have the two different functions that we are going to create from this, and it's important that we are only allowing these changes to happen if we are the host. So let's check if we have state authority. So if we're the server or host. If we're not, then we're going to return and do the same thing on make active ragdoll. Then let's change our state here. So if we have started our or making ragdoll, then is active ragdoll is going to be false, and vice versa on this is active ragdoll true. Then if we are becoming a ragdoll, we need to change our joint drive. So let's access our joint drive. So joint drive is equal to main joint slurp drive. So then we can change our slurp drive value here. So let's take our joint drive, position spring, put it to 0. And then we need to store that as our main joint here. Main joint slurp drive is going to be joint drive. Then we have updated that value, and the same thing if we are going in back to being a active ragdoll, then we need to restore our value. So in that case, it's going to be our start slurp position spring, and that will sort of bring back our ragdoll to being an active ragdoll again. And let's just change this to the final value. So that's the last thing that we're going to do. So there's the rough part of it, and we can add an event. So if we do, let's add it here, void on collision and on. I'm not sure why it's not auto-populating. On collision enter, collision. Let's just call it collision. And if we are entering a collision, then let's make ragdoll. Call that function. Then we become an active ragdoll, or a regular ragdoll, and then let's add some button later on to restore ourselves so that we can stand up again. But for now, let's leave that. The problem with this is that the different parts of our character will not react. It will just be our sort of the main joint drive that ensures that our whole character is standing up, but we want each joint to react to this. So we need to be able to handle that. And the easiest way to do it is to enhance our sync physics objects here, because this is responsible for each joint. So let's do the same thing that we did before. So let's add our start slurp position spring. And when we are awaking, then let's store the values. And then let's make a public void make ragdoll. And let's do another one called public make active ragdoll. And in our make ragdoll, we are going to do the same thing as we did with our main. Let's take our joint drive here, and let's put the position spring to 1. You can put it to 0 if you want, but it becomes a little bit too floppy for my taste. So let's allow it to stabilize a little bit. So let's put it to 1, and then we need to store back the value. So there we go. And then we do the same thing for the active ragdoll, but instead we are going to use our start slurp position. Okay, so if we go back into our network player now again and have a look at our make ragdoll here. So our make ragdoll is going to do, after we have changed our main joint here, then we are going to do the same thing for each of our sync physics objects. So let's iterate through them. And so for int is equal to 0, I is less than sync physics objects dot length, and then we go through each of them, and then we can just call our newly created function here. So sync physics object make ragdoll, and let's do the same thing for active ragdoll. And instead call make active ragdoll. So let's store this and try it out in Unity and see what happens. Okay, so now our character fell down, and the reason why we fell down is, well, I hit the ground. So that was not probably what we were thinking would happen, but yeah, it shows that our active ragdoll is at least working. But I can slide around when I'm an active ragdoll, or when I'm a regular ragdoll. So that was sort of, well, not intended. So we need to make a check for that, and we need to also check that this part has been hit and not something else. So how do we do that? Well, the easiest way is to add some tags to it. And this swiper, maybe we should separate it as well, so that a character can, for instance, stand on top of this part, while being hit by this part would be bad, but being hit by this part shouldn't be bad. So it should be able to stand on top of it while it's rotating. So let's open our object here, and first of all, let's get rid of our mesh collider. Then let's add some children here, collider, swiper, and then let's add another one. Oh, not shallow, that one. So let's add a capsule collider, and maybe 2, and bring it up a little bit. And it's a bit thick, right? That's good enough. Maybe it should be a tiny bit smaller. And then just move it up. It doesn't really matter if it's sticking right now below the surface. Well, so we'll just leave it at that. And then the swiper, let's do the same thing. Capsule collider, and height 2, and then we are going to rotate it by 90, and then just move it around a bit. And radius 0.4 will probably be good. And just bring it down in size a bit. Okay, so now that's good enough. So now that we have our collider swiper here, we need a tag to it. So let's add a tag, and in this case, let's call it cause damage. Because maybe we want to add some swords or some axe that swings and hits the player, and we will just call it cause damage here. And you can call it anything you want, but you need to separate at least our tag here. And then let's go back into our scripts and open our network player here. And in our collision, let's check if collision transform compare tag is equal to our collision, then let's not collision, cause damage. In that case, if it is cause damage, then let's make a ragdoll out of it, otherwise we're not going to do anything. And let's look at our code so that we can't move if we are an active ragdoll. So main rotate target towards direction. So here we need to look at our code and move in if our input magnitude is not equal to 0. And in this case we can say that, okay, and is, or rather let's add that check before, if is active ragdoll, then we are going to allow this movement stuff. And as well with the jumping. And if not, then we are going to just ignore it. So that should avoid our active ragdoll from moving. and shouldn't cause any more sort of problems. So let's save that and go back into Unity. And I did a boo-boo in the script, so let's fix that real quick. Add another parenthesis and it's done. So let's go back and let it compile, and then let's try it again. Okay, so now let's try it. So now we didn't fall down instantly, and if we are getting hit by this swiper, well, it didn't really trigger. And so why is that? Why didn't it trigger? Now it triggered. Well, it is because if we look at our player here, we have our model, right? And our sphere collider is the thing here between the legs that we were using for stability. And that is the only thing that is reacting to our event right now. So if we're getting hit in the head, it doesn't really matter, because the head has its own rigid body that takes care of that event. So the event is never sent up to our sphere or our main character. The only time it works is when our sphere here in the middle is getting hit. And to be honest, maybe we want to cut the player some slack. So for instance, if we are getting hit by the swiper on the legs, maybe we should just let it get hit. And the same with the arms. But if we're getting hit in the head or in the torso, then maybe we want to trigger this ragdoll effect. So we can change our scripts to make sure that it can detect different hits from different parts. So for us to do that, let's add a new script under character, and let's call it detect collision, and open that in Visual Studio. So the detect collision will be responsible for detecting what part is being hit, and it will be attached to the game object of, for instance, the head or the torso or whatever part we want to detect. So first of all, we need some references. So let's add our network player as a reference, and then we will want our rigid body that is being hit, so our own part. And why we want our rigid body here is we want to increase the effect of the hit. So as we saw when the swiper was hitting us, it didn't really produce an awesome effect, and we want more of the whole thing to feel like a game. So if we are getting hit by something, we want to sort of our character to fly a little bit further and well, react a little bit more like it's being hit by something. And so let's do our awake here, and in our awake let's get our different parts. So let's get our network player here. Get component in parent, because this body part is going to be a child of our parent. So let's get component in parent the network player, and the same, well, not the same thing with the rigid body really, because it's going to be sitting on top of our game object here. So in that case we're just going to use get component. Then let's get rid of our update function, and let's react to our on collision enter, same as we did before. And the first thing that we need to check is, as always, do we have state authority? So let's check network player has state authority. If it doesn't, then let's return. The clients should not react to anything, so it's only the host or server that should act on this. And then we need to figure out as well if we are in ragdoll mode or not. So our network player here, let's move it up. It keeps track of this, right? So we have this state here is active ragdoll, which we need to access from our detect collision. So let's do a public is active ragdoll, and we'll do it as a property. Public, and it needs to be bool. So now our detect collision here can access that script as well. So if not, so we are only going to make this check, or the check is going to see that, okay, if we're an active ragdoll, if we're not, then it's just going to return, and we're not going to add more force or do anything more to it. And then we need to check our object that we are getting hit by here. So is it something that can cause damage? So if collision dot collider compare tag cause damage. If it can't cause damage, then let's return. So in that case, we're not doing anything if it doesn't have cause damage. So now we have determined that okay, we are the state authority, the ragdoll is active, and it's something that can cause damage. So in this case, we are going to well, act upon it. And the first, well, let's do one more check, because there is a edge case that we can take care of. So imagine that we take a sword and stick it into our player's hand, and we're adding the tag cause damage because we want the player to be able to hit other players. But what happens if we suck at swinging our sword or club or whatever it is, and we accidentally hit ourselves? In that case, we're going to knock ourselves out, which could be fun, but it could also be annoying. So let's make it sure that we have a check for that. So if our collision collider dot transform root is equal to our network player transform, so if the roots are the same of our network player as the object that we're getting hit by, then we are saying that, okay, it's actually our own object that is hitting us, and in that case we are going to ignore it. So that would take care of that. Then we want to figure out, okay, what is hitting us, so that we can get some more details of our collision. And there is a feature for it. So collision get contacts, that allows us to get the information about each point or each contact point that has caused this collision. And we want to get those instead of relying on the sum of everything, to make sure that we can produce an accurate physical response to the character, so we're like throwing it in the right direction. And this contact needs to have contact points as an array, and to avoid creating garbage, we are going to create it once and then reuse it. So let's make a contact points an array with new contact points, and let's add 5 to it, so we can detect 5 different points at any given time. So there we go, and this returns an integer, how many of the points were used, or how many was detected. So let's do an int number of contacts is equal to get contacts. So in this case, we can iterate through them. So let's do a for int I is equal to 0 less than number of contacts I++. So we're iterating through all of our contacts here. And then let's get our contact point, and let's get it from the index I. And then we can do some more checks if we want to, but in this case we are just going to pick the first one and be happy with it. Later on it could be useful to iterate through multiple of these and make sure that well, they're in the correct direction, or whichever has the highest velocity will be the one that we are going to use. But yeah, let's just pick the first one. And then we need to calculate our impulse here. So there is already a contact point impulse, but if you look at in the manual, we need to do some more checking here to make sure that we are getting the value from this specific frame when it happens. So let's do a vector 3 from this, or actually let's add a get, so we know what we're doing. Get the contact impulse, and let's do a vector 3 and call it contact impulse, and then we'll take our impulse and we'll take time dot fixed delta time. So that will bring out the impulse on that specific sort of frame and not the combined value. And then let's do a check on it, because if it's like a tiny impulse, then we probably don't want to do anything about it. Like if somebody's, if you're getting close to this swiper but it's not really hitting you, and then let's not do anything about it. So we can think about it, if we are very close to the center of the swiper, the impulse will be less compared to if we're far out on the swiper, because the impulse will be bigger in that case. So if we're in the middle part of the swiper, maybe we just wanted to push us around and not get knocked out. So let's add some random check for this, and we are going to check if the magnitude is less than 15. I mean, this is a value that you can tweak and find what works best for your game, but let's just start with 15 and see if that's good enough. So if it's less than 15, then we are again returning, so we are avoiding, and return is actually not very good here. It's better that we do a continue. Continue, there we go. So continue will cause this for loop to run again and find another contact point, because maybe one of them has an impulse that is bigger than 15. So let's just run through all the contacts and check that we don't have anything that is bigger than 15. But if we do, we need to do something about it. And we need to talk to our network player here and to be able to say that, okay, something was hit. Let's add a new function here. We can do it through events, but yeah, let's just make it quite easy. So instead of this on collision enter, we're not gonna use this anymore. Let's do a public on player body part hit, and it's gonna be a void. And if we are hit, then we want to check if we are an active ragdoll already. So if not active ragdoll is active ragdoll, then let's just return. Otherwise, we are going to call make ragdoll here. So now we have a function that will trigger this, and let's use our detect collision here, and in our collision let's check network object, network player, and let's call that function. So now we have called this function. It has iterated through all of our different parts, and everything is now a regular ragdoll. And after it has become a ragdoll, we can apply some forces to it. So let's take our force direction here, so the direction that we want to throw or affect the player in, and we'll take our contact impulse, and then let's add a little bit of up to it. So if something like the swiper is hitting you, then we want the character to go up a little bit off the ground, so the friction doesn't stop it directly. And it is a little bit big still, so let's just reduce it by 0.5, and that's a value that I found works quite okay. And then this force can get extremely big, and if it does, we don't want like the character to be thrown off the map like several hundred meters away. Instead, let's just limit it so there's a max force to this. So let's take our force direction and say, okay, vector 3, clamp magnitude, force direction, and put it to 30. That way it can never get bigger than 30. And then we can draw a debug ray to figure out, okay, what is the direction correct. So let's draw a ray, and let's take our position here of our hit rigid body position, and then let's take force direction, and let's just make it a little bit bigger. So multiply it by 40, color red, and then we will keep it for 4 seconds, and after that this draw ray will disappear. And now that we have done that, let's add our force hit to it. So let's take our let's just increase the effect of the hit. Let's write that as a comment, and then we'll take our hit rigid body, add force, and it's going to be force direction, and let's take force mode, and let's use impulse. So that will cause this specific body part that was hit to get sort of a hit based on the direction of our impulse. So based on the direction of the hit, the contact point's impulse. So let's save that and try it in Unity. So let's find our prefab, our network prefab, our character, and let's open that, and our rig here, root, and let's go for our hips, spine. So let's have our spine do this, detect collision. So if we are getting hit in this area, then we are going to react to it, and the same thing if we are getting hit in the head here. So let's add that, detect collision, and let's save it. And now take first spin. Alright, so here we go, and if we are jumping, then yeah, there we got hit in the side, and now we can't move. So we need some way of restoring our movement, so we need to figure out how to do that. So let's open our scripts, network, and let's open our network player. So we need to add a feature here, same as our jump button. So is grounded, is jump button pressed. So let's do a bool is revived button pressed, and let's put it to false as a start. So our revive button is going to work the same way as we are handling all our buttons. So let's just add get key down space, and let's use the R button is revived button pressed true, and in our input we need to get it in our input here, so that we have a network input data is revive button pressed. So let's go and open our network input data. You can access this by holding down the control button and then pressing the network data, and it will open this. So let's do a public bool is revive button, revive press. We didn't have button here, so let's stay with the same way of naming, the same naming convention as we used. So is revive button pressed. Then let's do network input data is revive button pressed and put it to true. And then reset buttons. So now we can detect if we are getting or if we are pressing our revive button, and if we are pressing our revive button, we need to do something about it. So if we are active ragdoll here, and let's figure out how we should do this, right? So if we are an active ragdoll, then nothing should happen when we are pressing the revive button. But if we are not an active ragdoll, then we can check this. Okay, if is revive button pressed, but maybe we should have a way of figuring out, okay, if we're getting knocked down, should we be allowed directly to stand up? I think that maybe we should add some delay to it. So if we are if we add a delay to it, we can check that, okay, when was the last time that we were hit by something? So let's store that timing. Last time became ragdoll. So in our make ragdoll script, wherever it is, make ragdoll here. So let's store our time here. And our time, let's make sure that it's network time. So let's do a runner.simulation time and store that. And in our check, let's go back to where we were. So here. So let's add a check that, okay, if we are network, if the revive button is pressed and our runner simulation time minus last time became ragdoll is bigger than 3 seconds. In that case, we are going to allow it to make active ragdoll. And if not, then we are going to stay as a ragdoll. So let's try that. So let's try it out. Alright, so let's get hit by this thing, and yes. And I hit the R button to revive. And yay! Now we're getting, oh yeah, maybe when we are resetting, we should reset, right? So the reset function should take care of this problem, that we don't need to press the revive button. But for now, yeah, let's just leave it. So yeah, and actually didn't work. So I was able to revive directly, I think. Let's try it again. So yes, something is wrong with our code. Because I can revive instantly, which was not the point, right? So let's go back into our code and figure out what is wrong, and as well let's revive the player if we are getting resetted because we are falling through the ground. So let's see, where is our check? So yes, here is our check when we are teleporting the player, because they have fallen off the ground. So in this case, let's make active ragdoll. And then let's check why it's not considering our time here. So make ragdoll. Oh, okay, so the last time became ragdoll is in make active ragdoll. That's the wrong place. It needs to be here. So in this case, we are happy with it. Make ragdoll. Now we are storing the last time became ragdoll. So now it should work. Let's try it in Unity again. And let's find another obstacle. So let's find another one. And I think there's some nasty looking spike roller. Yes, here we go. So we have our spike roller here. So let's add our rotate network object. And let's add our network object to it and then rotate it 300 so it's a little bit faster. And we need a mesh collider on this. And let's make it convex. So convex will be a little bit faster and it will just take care of the outer edges. And as this is rotating fairly fast, it doesn't really matter if we are sort of hitting in between this. Well, it doesn't really matter. And then tag cause damage. And let's make it a prefab as well. No, it needs to be in the level parts. Okay, so as well here maybe we should make on the top we want a player to be able to stand on top of that without getting hurt. So let's make a small hack for it. Let's create a child and let's do a box collider. Nobody will notice. And bring it up and make it quite small. No. Let's rescale the whole thing. So, something like that. That will allow somebody to stand on top of it without dying. And let's call it extra. So I'm not getting confused what it is. Okay, so let's take for a spin. And now we should be able to revive within 3 seconds and have this nasty thing as well in there. Okay, so now I'm hitting the revive button and nothing happens, and yes, 3 seconds passed. And then, yeah, okay, so there was some massive force on that one. Let's try it again, and yes, I'm getting thrown away. Perfect. And now we can add some interesting things, because we are detecting which body part. Well, the force wasn't enough to knock us down actually, so now I was properly knocked down. And let's revive, and yes, I got knocked out again. So now we can add some more interesting mechanics to our game. Like we can add a sword that allows us to fight against other players. And we can add our shield, which allows us to protect from things like that. So let's try that and see that our collision system is working. So let's take our character here. So let's open our character prefab, and if we have a look at our upper arm right, then in our hand slot there is a sword. So if we enable our sword here, then let's add a box collider to it and add cost damage. So now let's just edit our sword box here a little bit. We don't want the edge of it to hurt somebody. And let's just bring it down a little bit. No, too much. And let's just make it a tiny bit smaller. and it's too wide, right? So let's bring in the sides, something like that. So that would allow us to hurt somebody with the sword, hurt another player. And then let's do our left arm here, and let's figure out if we can do a rectangular shield here, and let's add a mesh collider to that and make it convex. So our little dude here will now be able to defend himself with a shield, and but he's carrying it slightly weirdly. So let's try to figure out what we can do with that. And let's see, if we take our wrist or lower arm to start with, let me figure this out. So let's do that. We'll rotate it in this way, and then let's do 90 degrees, something like that. That will bring a shield to the side, and then and then if we bend the arm, it should be okay, I guess. Lower arm. So let's bend that a little bit, not in that direction. Too much. Yeah, something like that. Then we can be able to protect ourselves. And our right arm here, we need to increase the configuration or our joint, so it's a little bit stronger. Because it's going to be flopping around a lot. So let's try 5, see what happens, and then take for a spin. Yeah, well, he's not carrying his. We need to increase the strength of our shield arm as well, so it doesn't flop so much. But let's go around here and see if we can use our shield. Ooh, nope. We need to increase our strength in our arm so he can protect himself with the shield. So yeah, let's do that. Let's go into our character again, and let's bring our shield arm, which is our left arm, and let's make it less floppy. So position spring 5. Let's try that and see if it works better. Yes, well, a little bit better at least. So now we can see that the shield is protecting us. It's not killing us because it's not hitting our body. Well, there it hit our body. And we can do the same thing with the swiper if it only hits the shield. So there we go. Now it hit the shield, and our character is sort of wobbling around and it's being protected. But as soon as something goes further and the shield is not protecting us and hitting the body, then we are going to get hit anyway, like that. So, well, you can experiment with this shield mechanic if you want. And now we have our sloppy character, and let's try it with our client to see if it works and see if we can hit the other client. And probably we should add some animation to allow us to control the hand a little bit better, but let's see if we can bring up enough momentum to kill another player. So let's bring in clients. So now I have our host here and our client here, and we can see that, yeah, well, there is a problem, and the rotations of the objects are not updated on the client, but in fact they are, because I can get hit on the client side, it means that it's working on the host, but it is not visually working on the client. So what did we miss? Well, we forgot to add one really important thing here, which is going to be the network. Oh, sorry, not network. Transform. Network transform, yes. So the network transform needs to be added, and as I added it here, I need to just apply it to our prefab as well. And let's do the same thing here. Network transform, and then let's just apply it. So now it will work on the client. So that was a good example what you need to do for this to work. The other option is to use our network physics instead, and then assign our rigid body here and add a rigid body to it. But we're just going to use our transforms. So let's compile again and try it again. So let's bring in our host. Here we go, and let's bring in our client. So here's our host, and here's our client. So now we can see that yes, our rotations are working. And let's see if we can stab our host. Well, our host stabbed the client. So before I had a chance to get my sword on him, well, we need to, maybe if I jump instead, needs to be forced. Yes, I managed to kill him. Yeah, the host can of course kill the client as well. So let's just get enough force. Yes, I managed to. Well, then I got killed by him. So yeah, now we have a quite crazy game mechanic here, where I can have a bit of a fight with my fellows warriors or knights, and I can enjoy getting killed by the environment. And if we look at this arm, just one little thing, it's stuck, and it's very floppy, our characters, right? So one thing that we can do to reduce this is to increase damping. So damping on different joints will cause them to become a little bit more stable. So we can compare it to this, and let's just increase the damping. So let's go to our character, and let's take our legs here, and let's add dampening position damper 1, and the same with our spine here. Let's add 1 to our damper, and our upper arm and right arm, let's add 0.5, and our right arm, let's make it a little bit stronger, 7. Now one thing you can do is add this animation. So whenever somebody's clicking the mouse, it will cause our animator to trigger a hit animation, which makes it easier to get some speed with the sword and make it less predictable. But yeah, that is something you can add on your own. So let's save this. Then there is this one tiny thing left that will improve, and that is that our character is playing the animation even when it's a ragdoll. So let's find our code here, and so we have sync physics object update joint from animation, and that is being played even when we are a ragdoll, or when we are a real ragdoll, and it should only be played when we're an active ragdoll. That's why we can see that like the feet are moving when we are getting knocked down. So by checking this, we can ensure that that doesn't happen. So now I'm going to save this and compile some clients so we can take it for another spin. Alright, so now I have my host here, and let's see if I can, well, now I got stabbed by the client. So let's revive. Yes, I scored a hit. And now that I've changed the ragdolls, they are no longer sort of moving their feet when they are dying, and yeah, It also changes a little bit the behavior of the body because they are not getting any animation information that they're trying to sort of correct. So let's see if we can score a better hit on our client here. Whoop. Yes, so yeah, he died standing up and now he fell over, so that's cool. Another thing that we can do now that we have this up and running is we can have some sword play, because as you see, if I swing my sword here and I hit his shield, he doesn't die, but with the point I can hit him. So we can create some interesting gameplay mechanic from this, because yes, if I swing my sword on his shield, he won't die. So by making maybe the sword hand a little bit, or the shield hand a little bit stronger, we can create some real cool stuff. Hey, look at that. And yes, so now we have the basis of making some crazy, interesting, active ragdoll game. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. Thanks for watching, and don't forget to like and subscribe. I'll see you in the next video.